Hi friends, let's have a look at problem 3192. Minimum operations to make binary array elements equal to 1. This is the second of such problems. So actually, this problem is very interesting. So once you digest the main point of this problem, so the coding can be very short and very straightforward. So first, we are going to look at the problem statement, and then we analyze analyze the idea, or how we should process the coding. Then finally, we share the short code. So here we are given a binary array called nums. So we can do the following operation on the array any number of times, possibly 0. So we choose any index from the array and flip all the elements from index I to the end of the array. So flipping means change 0 to 1 and 1 to 0. So we want to return the minimum number of operations required to make all elements in nums equal to 1. So here we have two examples. So if you look at the second example, so the first element is 1, so we don't need to take care of that. And then we start from the second example. In other words, the first 0. So then we will change all the zeros to be 1. And so we'll just need 1 operations. Well, for the first example, so the first element is 0. So we need to, starting from this one, we do the flip of all elements. So we are going to get 0, we are going to get 1, 0, 0, 1, 0, right? So then we start from the second one, then we can get all zeros. So I guess here in this explanation, so it gives us a different way to do the flip. Let's look at the walkthrough. That might be better, so that we save some time to explain the ideas. But I also want to mention that we need to pay attention to the constraints, right? The length can be as long as 10 to the power 5, and in other words, we need to think of time complexity. So let's look at an example here. So in view of the operation, because the operation is that we fix the index and flip all the elements starting from the current index to the end of the list. So in other words, we need to start from left to right. Otherwise, so if you start from right, you cannot fix how many times a element is flipped, right? So we need to start from the leftmost 0. So we then do 1 operation. So here in the first example, so we get start from index 0. So we get 0, 1, 1, 0. Then we do the flip. We get 1, 0, 0, 1, 0, right? And then we get the leftmost 0 again. So this is from this one. So we flip this 4 element. So we get 1, 1, 0, 1. And then we need to find the leftmost 0 again. So this is corresponding to index 3. Then we flip index 3 and index 4. So we get 1, 0. Then we find the leftmost 0, so which corresponds to the index, this is the 4, right? So then we do the flip. So we get 1, 1, 1, 1, all ones. So in other words, the indices involved are 0, 1, 3, 4, right? For the first, we make 0, then we flip, we find another 0 at index 1. But if you ignore the flip, actually you first find 0, then you do flip, corresponding to find the first 1 in the original array. And then you do flip, and then in the third index, you need to find 0, right? So in other words, it's alternating, because 0, 1, 3, and 4 corresponding to 0, first 0, first 1, then first 0, and the first 1, right? Then if we do this alternating fashion and then count the number of operations, then we just need a for loop to finish the coding. So now let's realize this one, right? In other words, we don't need to do the flippings explicitly, right? So because we can track always always the left most zeros and ones in the alternating fashion. So this actually is mimicking the flipping, right? So now let's write the code. It's actually very straightforward. So result, let's see. This is the counting variable. We are going to return its final state. And then I'm going to use current. So because at the very beginning, we need to find the leftmost 0. And then we find leftmost 1. So in order to do the flip, we just need to use current equals 1 minus current. So this will realize the flipping actually, right? So now what we want to do is we do a for loop, right? If y equals the current guy we want to find, then we need to do one operation. So we do result is increment 1. And in this case, we're going to do the flip. Actually, this corresponds to the flip. But we are using a variable to alternately retrieving zeros and ones, right? So that's it, actually. So we just need to return the result state. So this forms a full solution to this problem. So let's do a quick check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So I found that this problem is an interesting one. So here, actually, it demonstrated that how a deeper analysis can help us do the coding. So certainly you can also do the flippings explicitly and then do the countings, but that actually use some extra time. So with that said, I guess that's it for the current problem. Yeah, thank you.